Have you ever stopped to think about the invisible kingdom that's hiding all around us, in plain sight? It's this world of incredible force humming away quietly behind our walls, literally powering our entire civilization. Today, we're going to dive into the absolutely fascinating world of power engineering. I mean, think about it. It's something you do dozens of times a day, probably without a second thought. But what are you really doing when you flip that switch? What kind of command are you actually giving? See, you're not just closing a little loop of wire. You're mobilizing a force of nature. You are commanding a literal army of electrons, telling them to get up and start marching on an epic journey that might have started hundreds, maybe even thousands of miles away. So, that's what we're going to do. We're going to follow this army on its entire journey, from its very creation across these vast electrical highways and all the way through to its final destination in your home. All of it made possible by the incredible science of electrical engineering. So where does it all start? Well, it begins at the birthplace of all power, the generator. This is the spot where the electrical energy that runs our world is first, well, brought into being. And let's be clear, we are not talking about small machines here. We're talking about colossal, spinning hearts where raw physical force, from steam or wind or rushing water, is transformed. The forces at play inside are just immense. We're talking about the mechanical equivalent of a thunderstorm, all contained and perfectly controlled. Now, a generator doesn't just create energy out of thin air. It's a masterful converter. It takes the energy of motion, that's kinetic energy, and using the fundamental laws of physics, it persuades electricity to flow out of these super powerful magnetic fields. If you could peek inside, you'd see a spinning part, called the rotor, moving inside a stationary part, the stator. And it's this incredibly precise rotation inside a magnetic field that gets that army of electrons marching in a perfectly synchronized rhythm. It's really a beautiful, powerful dance of physics in action. Okay, so once that power is born, it can't just stay put, right? It needs to travel. And it travels on a vast, invisible superhighway that crisscrosses entire continents. But before it can hit the road, the electricity needs a special kind of passport, and that is the job of the transformer. The best way to think of it is as a linguistic translator. It doesn't actually change the power, just the language it's speaking. In this case, it's voltage. So the way it works, basically, is you've got these coils of wire wrapped around an iron core. By changing how many loops are in the coils, the transformer can step up the voltage to incredibly high levels, which is perfect for efficient long-distance travel, and then step it down again so it's safe enough to come into our towns and homes. And this is what that highway actually looks like. These transmission lines, they're like the great arteries of our civilization. They carry the lifeblood of electricity across huge distances, making sure that the power born in some remote power plant can light up a city 1,000 miles away. Now, all of this, the generators, the transformers, the miles and miles of power lines, they're all connected into one single massive entity that we call the grid. And honestly, it's best to think of it not as a machine, but as a living, breathing creature. The grid is this incredibly complex, almost biological web. You've got power flowing in from all kinds of sources, and it's all routed through this network to every factory, office, and home. It is a delicate, interconnected system that has to be kept in perfect balance 24/7. And that whole balancing act, it comes down to a single vital number. Depending on where you live in the world, it's either 50 or 60 hertz. This number is the frequency of the alternating current. It is, and this is no exaggeration, the steady heartbeat of our entire technological civilization. And engineers are watching this pulse, this heartbeat, constantly. If the frequency goes even a tiny bit too high, it means there's too much power being generated. If it drops too low, it means the whole system is straining to keep up with demand. It's this constant, real-time balancing act that requires unbelievable precision. Which, of course, brings us to the people who manage this entire invisible world, the power engineers who pull off this incredible feat of control every single second of every single day. And this is where we run into this amazing paradox. The work of power engineering happens on two totally different scales at the exact same time. It's about dealing with forces that are truly colossal, but controlling them with a delicacy that is just mind-boggling. And you can see that contrast so clearly right here. On one side, you have the raw, chaotic, untamed power of an electrical arc. It's basically man-made lightning. And on the other, you have that exact same fundamental force, but it's being wielded with such mathematical precision that it creates these beautiful, intricate patterns. It's really engineering at its most epic. So we end up right back where we started, with you, and a simple everyday action. The next time you plug in your phone or turn on a light, just take a second. Think about those colossal generators, the vast electrical highways, and that constant, steady heartbeat of the grid that makes it all possible. What invisible world will you imagine working for you now?